All right, guys. So in this case, we are going to consider our typical exam revision, which is for our mathematics N3. So if we are to consider here, this is our 31 July, that is the August exams that you're going to consider for mathematics N3. So make sure that you go through the information, the instructions that you are being given. Make sure that you go through. Remember, this is a 3-hour paper, okay, out of 100. So in this case, make sure that you go through every part of the instruction. And in this case here, it is important here. It is important that you do show all calculations and intermediate steps. Then all final answers must be accurately rounded off to 3 decimal places. All right. Then techno diagrams are not drawn to scale, and all graphs must be done in the answer book. A pencil may be used, right? So take note there, you're supposed to do your graphs in the what? In the answer book. So meaning to say we do not have a part where you're going to have an extra graph paper. You're going to sketch whatever that you sketch there, the graphs, you sketch them in your answer book. So that is the major part, guys, of our instructions. So let us quickly go through our questions that we are being given. On question number 1, that was 1.1, factorize the following as far as possible in prime numbers. That is considering prime factors. All right. So we are given in this case, guys, that is 1.1, x to the exponent of 16 minus 30, x to the exponent of 8. So this is the square root of y like this plus 225 y like this. So guys, I want you to be careful in your revisions in your N3. Knowing some of the things can help you to understand that how are they going to ask questions. In your N3, guys, they are going to be playing around these algebraic identities of your algebra. So in our algebra, we have got identities. The first part is this one that you are given from your formula sheet. So this first part you are given, then the other ones that you're not given that I'm going to write. So these ones, the factors, a cubed minus b cubed. They want you to, they are testing you about these factors. And also, so this is the sum of sum and difference of two cubes. So these are two cubes. Remember, we've got the difference of two squares. We do not have a sum of two squares, guys. We have a difference of two squares. All right. That's another part that you need to consider. But in this case, as you can see, guys, 16 and that cube, we do not have such. And also, they want you to figure out these expansions, a minus b squared, this expansion of a minus b squared, which is equal to a squared minus 2ab plus b squared. And if it is a plus, a plus b squared is equal to a squared plus 2ab plus b squared. Always try by all means to figure out this. Once you see it's not part of factorization where those sum and difference of two cubes is not involved, like here we cannot talk about that, guys. So here we have to consider something of this nature. This is a trinomial at the end. We have got three terms. We have a trinomial at the end. This is what we have, a trinomial: 1, 2, 3. 3 terms. So in your factorization, they'll actually, guys, they'll be into these perfect squares. They'll be into this. So if you understand this, guys, it was just for you to figure out, all right, because here you've got perfect squares. Why am I talking about those? We can see the first term because in our case, we have got what? We have got a negative here. Take note, we have got a negative. So meaning to say, definitely, we have to think of something of this nature, a minus b squared, where this is a and this is b. Take note, this is the same a that you have here. The same a that you have here. The same b that you have here, the same b that you have there. So because of a negative here, we are supposed to what? Consider that this must be what? Negative. We have a negative here. So is it going to be in this format? What does it mean? A squared. It means a term. The first part here must be raised to the exponent of what? 2. Is it possible for us to have this to the exponent of 2? Yes. This is x to the exponent of 8 to the exponent of 2. Remember, exponents, you multiply 8 times 2. This is the same part that we have here. Minus 30 x to the exponent of 8, the square root of y like this. So take note, the last part here is b squared plus b squared. And you can see we have a plus. 225, this one is a perfect square. We know the square root of 225. So for a perfect square, let's say we are given a 4. How do you know the number that you're going to use? We know that it's 2 squared. But how do you know this number here? You simplify in the square root. The square root of what? Of 4 is what? Is 2. So if the square root of 4 is 2, then you know that 4 is same as what? 2 squared. The square root of 9 is 3. So meaning to say 9 is equal to what? 3 squared. So if you understand that, guys, that we need a square. So we simply have to determine what? The square root of this part. What is the square root of 225y? Square root of 225 is 15. What about the square root of y? Do we know the square root of y? We cannot simplify the square root of y, so it remains like this. So it will be 15 square root of y squared, so that it gives us this. So that it gives us that part. Guys, if you are to expand this, 15 square root of y like this one, squared. If you expand this, it will give you this exactly. 15 squared is 225. Square root of y squared means the square root of y times square root of y. Remember, it will give us y there. So understanding these, guys, it was going to help you. Because you can see this is exactly the same format here. A squared minus 12. This is exactly the same format. So in our case, what represents our a? This is our a, x to the exponent of 8. Our a. What is our b? Our b is this part, the last part that is being raised to the exponent of 2. B squared. A squared, b squared. We just need to know what is our a. So this is our a, x to the exponent of 8. What is our b? Minus, what is our b? This is our b. The square root of what? That is 15, sorry. 15, the square root of y like this. Everything is raised to the exponent of 2 in that bracket. A minus b squared. That is how to factorize. So it's a minus b what? A minus b squared. From that expansion of a minus b squared. So this part, guys, you must know it. Used to factorize perfect squares. These are perfect square expressions. Any form of a perfect square. Any form of a perfect square is used to have that. You are given x squared minus 4x plus 4. It's a perfect square expression. Take looking into the first and the last. You can see that 4 is same as 2 squared. So if you understand this, the product minus 2ab, this part here, if we say minus 2 times a times b, which is our a, in this case it's x, our b is what? Our b is 2. If we multiply this, you see that we get the minus 4x. So meaning to say this x squared minus 4x plus 4, it was taken from what? X minus 2 squared. A minus b. So our a is x, our b is what? 2. A minus b squared. If you know this, guys, it can be used especially in complicated expressions like these ones. If you understand that, it was going to be easier. All right, on 1.2, so guys, simplification, there are so many ways. As long as we've got the same answer there, that is what is important, because we cannot finish, guys, to say simplification so many ways. Again, here, simplify the following expressions, right? Completely for 6 marks. All right, so this is the whole expression that we're given on our 1.2. So we're given this was 1 minus 1 over x plus 1, everything like this, into 1 plus 1 over x squared plus 1. So if you are to consider, guys, these are two fractions, one on the numerator, another one in the denominator. So understanding this can help us to separate them so that we can properly simplify. Check this on its own, 1 minus 1 over x plus 1. This part here on its own. Also, we take the denominator on its own. So this is same as we're going to put a bracket here. So let us just have a bracket like this. So this is a division. This one, we are dividing. There's a division. So it means divided 2. All right, you open a bracket, you put this one. So that's 1 plus 1 over x squared plus 1, just like that. This is the simplification. What does it mean? So meaning we can simplify this on its own. We can also simplify this on its own. Subtraction on this part, addition on that part. Remember, simplification of your algebraic fractions, finding of the LCM, LCD. This is same as what? Over 1, 1 over 1. So you can find the LCM of 1 and x plus 1. This will be what? X plus 1. So you divide x plus 1, divide by 1. It's x plus 1. Whatever that we get, we multiply to the what? To the numerator. So it's 1 into x plus 1 minus x plus 1 divided by x plus 1. That's a 1. So that 1 multiplies this 1. So it's just like 1 times 1, guys. All right. Divided 2. So this is a single fraction now, which will be divided to the single fraction that you're going to obtain from this part. This is the same as what? 1 over 1 again. So the LCM or the LCD of these two is going to be what? X squared plus 1. So let's divide. LCD or LCM to this one, you're going to have x squared plus 1, which is multiplied to the what? To the numerator. So it's 1 into x squared plus 1 plus x squared plus 1 divided to this. That's a 1. Then 1 times 1, that's a 1. Guys, 1 times 1. This is just a 1 here. Just to appear together. Also, simplification, guys, different ways. You can even change this one to the denominator of what? X plus 1. So it will be like this, x plus 1 over x plus 1 like this, minus 1 over x plus 1. So it allows you to simply combine the numerators under the same denominator. So it will give you x plus 1 minus 1. These two cancels, so it will be x over x plus 1 from this one. The same thing on this one. You can even write it as what? In the denominator of this one. So it will be x squared plus 1 over x squared plus 1. Then you add, it's an addition. This one, you add whatever that you're given there, knowing that if the denominators are the same, you're simply going to combine what? The numerators together. So that was the case. So meaning to say, guys, different ways of simplification. So if you are using this, you're going to expand the brackets, then collect like terms. 1 multiplies everything. 1 times any number, guys, it remains as it is. X plus 1, 1 and 1. That's minus 1 times 1, which is negative 1 over what? X plus 1 divided 2. Here you expand by 1. So it will be x squared plus 1. 1 times 1, that's a 1 like this, over what? X squared plus 1. All right, so this is where we are. Did I take this part correctly here? All right, this is actually here, x squared minus 1. X squared minus 1 from our question, guys. Everything has just been affected here. You see, guys, this thing of writing aside of the question This one. So it simply means even my denominator here, even here, it's affected because it's going to be like this, to be like this. All right, so this is the part of what? Here. It's x squared minus 1 there. So meaning to say that here we can simplify. Let's see. So guys, just make sure you go through your revisions. Yeah, like when you're writing, it can happen. These mistakes, part of your simplification also. So let's get rid of your numbers here. The 1 minus 1, that's a 0 there. So you're going to remain with what? That will be x over x plus 1 divided 2. Let's consider here, you've got like terms there. Minus 1 plus 1, that will cancel. And you've got x squared over x squared. Remember, this is what? Minus 1. Okay. So with this part, we have a single fraction. We also have a single fraction here. So we can introduce our multiplication. So multiplication now is best because we've got single fractions. Remember, the moment that you introduce a multiplication here, you are going to interchange or invert the second fraction. So this will be on top, this will be below, just like that. So you write this on top and you write this one below. You interchange. So that will be x squared minus 1 on the numerator. The x squared in the what? In the denominator over what? X squared, like this. So this allows us to divide as long it is between the numerator and the denominator. But if we've got expressions such as x squared minus 1, try to factorize there. It's a quadratic expression. The highest exponent is 2. What type of a quadratic expression? This is a difference of 2 squares. Remember your difference of 2 squares, guys. A squared minus b squared is equal to what? A minus b into a plus b. So 1 same as what? 1 squared. So that's a difference of 2 squares. Square root of x squared, the square root of 1. So that was going to be x over x plus 1 times. So the difference of 2 squares, we're going to have 2 brackets, x minus 1, all right, into x plus 1. Everything over what? X squared. So take note, 1 is a perfect square. So mostly you might leave that part if you do not understand your difference of 2 squares properly. That 1 is a perfect square. So be careful. So looking into our numerator to the denominator concept, let's see here, we've got x plus 1, this can cancel. X into x, that's 1. X into x squared. Take note, there are 2 of them. So if you cancel, it's going to remain with 1x. So this is it, guys. As you can see, can combine the numerator to the numerator. 1 times this x minus 1, that will be x minus 1 over what? 1 times x, which is x. So that is it, guys. It was going to be x minus 1 over what? Over x. So we just have to be careful in our simplifications. So that was a negative, guys, there. Issue of writing aside. But I just hope you're together. Just try to work out as many questions also as you can. 1.3, solve for x by completing the square, x squared. All right, let me just try have it here so that I can properly see it. This thing of writing aside, so to end up giving challenges here. So this was x squared is equal to minus 3x plus 10. So completing the square, guys, different ways of actually having application of this part of our completing of the square method. Like we can leave this constant this side. We can choose to move all terms to the other side. But let's just leave it here because we do not need this constant. So we're going to take the minus 3x to the other side of the equation. So it will be positive there. X squared plus 3x is equal to what? Is equal to 10. So you take this, becomes a positive, so that's equal to 10. So on your completing of the square method, remember that you will need half the coefficient of x squared, half the coefficient of what? The coefficient of x. So it must be half the coefficient of x, but being squared. So the coefficient of x is or x. What is its coefficient? The number that is what? Affecting x is what? 3. So you're going to need half of what? Half of 3 squared. Half of 3 squared like this. Half of 3, that is 3 over 2 from your calculator. That's 3 over 2 squared, which is 3 over 2 squared. That's 9 over what? 9 over 4. If you square this, you can write the 9 over 4. It's up to you, but you can even leave it. Just write this 3 over 2 squared. Remember, you're supposed to, if you're solving an equation, whatever that you add on this equation is supposed to be done both sides. If I put a 1 here, I'm supposed to also put a 1 here. That is to neutralize our equation. Whatever that you do on the left-hand side must be done to the right-hand side. So remember here, you need to complete the square here. We must complete what? We must complete the square on this part. So to complete our square, we are going to add the perfect square that we have here. This one, the 3 over 2 squared, or this one, the 9 over 4. It's up to you. But as for me, I'm just going to use this one so that I do not get confused in terms of the sign that I'm going to use. Yes, you can use the 9 over 4, guys. It's not even a problem. Or you can take this one, the 3 over 2. So you see the advantage of taking that 3 over 2 like this. So it's plus 3 over 2 squared. Remember, we added this. This is the perfect square that we added to make this to be a perfect square. We added something on the left-hand side. Whatever that we added must also be added on the right-hand side. So on the right-hand side, we've got 10. So we're going to add also that same perfect square, which is this one, the 3 over 2 squared, same as 9 over 4. So you must add it also here. Whatever that you added on the left-hand side. So if you see properly here, the left-hand side, we are going to factorize. That's a quadratic expression there. And to factorize that, we are back to that, guys, our a plus b squared. This is a plus b squared that we are seeing there. Remember, everything is under a positive, which is equal to a squared plus 2ab plus what? Plus b squared. Exactly this format. So they don't even worry to be of this format where this is your a and this is your b. Your a and your b. So knowing that, guys, you can see that this is our a and this is what? Our b. The numbers that are being raised to the exponent of what? To the exponent of 2. This one. X and the 3 over 2. Those are the ones that you take a and what? A and b. In the same bracket to the exponent of 2, you have factorized it. So it means it will be x. Remember, that's a plus here. So it's x plus 3 over 2 to the exponent of 2. That is how you factorize this one, knowing these algebraic expressions. So guys, revise this, even your grade 10 mathematics, factorization, expansion, these completing of the square in your grade 11, just your basic, it is important that you go through. All right, so let's add this part. So there, it is just a matter of your calculator. So you can simplify the remaining of this part on our calculator, guys. So let me just take our calculator. Okay. All right. So if you had to consider this part, okay, why am I having 2 of them? I just need 1. So this is 10. So you're going to have 10 plus, open a bracket there, 3 over 2 squared. So you open a bracket, that's 3 over 2 squared. So that was going to be 49 over what? Over 4. So that's it, 49 over 4. Taking note that this is a square. So you must get rid of that square. How do you get rid of the square? You introduce the square root. Now we are solving for x. So you're going to introduce the square root. So meaning to say we are going to have x plus 3 over 2 is equal to remove. Remember, you introduced the square root to remove that square. So you no longer have the square. You're just left with what? X plus 2. And what is the square root here? Plus or minus. Take note, the square root of any number is what? Plus or minus. So on your calculator, square root of the answer is what? 7 over 2. But with what? Plus or minus. So that's the case. So meaning to say, we can take this minus 3 over 2 to the other side. The plus here, sorry. This one, the plus to the other side. So it will be what? Minus there. The moment it crosses the equal sign. So x is equal to minus 3 over 2. The moment it crosses the equal sign. Plus or minus what? Plus or minus 7 over 2. Take note, there's already plus or minus 7 over 2. So this one can be simplified. In case that it cannot be simplified, guys, that's where you maintain those square roots. Even try to write it as a quadratic equation, the way that you write your quadratic equation, where you combine your terms, this and that. But in this case, guys, you've already separated. It's enough. So you can even separate our sign. Plus, another one carries what? A minus from there. So let's start with a plus. That's minus 3 over 2. Minus 3 over 2 like this. Plus 7 over 2. So that's plus 7 over 2. That's what it means. So the first one is going to give us what? 2. Or x is going to be what? We separate now. We take this one with what? A negative this time. So to the negative, what are we going to have? Simply going to change this one. Put a negative there. So it's minus 7 over 2 this time. So that was going to give us what? Negative 5. Just like that. Completing of the square method. So under exam condition, you are told to use the completing of the square method. Use that. And use the quadratic formula now to prove, because you are used to the quadratic formula, guys. So you use now the quadratic formula to prove your answers, to see if you are in the right direction. That is the case of exam. You are used to that quadratic formula. So you use that to prove now, to check if your values are correct. All right, so that was it there for 6 marks, which was actually fine. All right, 1.4, given this, determine the value of P if f of x is equal to this and gives a remainder of 15 when divided by this. So guys, I talked about this type of equation that I said, whenever you're given this, it is divided, whatever that you are given there, start by that one, determine the value of x from there. You are dividing by what? It's being divided by x minus 2, equate it to 0. So it means x is equal to what? Solve. X is equal to 2. Whether they said it's a remainder, whether they said it's a factor there, whatever that you're going to have here, the value of x that you have here, this one, x is 2. It means f of 2, the value of x, is equal to the remainder. That is the case. So meaning to say, if they say it's a factor, if they say this one is a factor, it means there is no remainder, guys. If there is a factor, if it is a factor, it means the remainder is what? The remainder is 0. There is no remainder. So that's why we'll end up with f of 2 is equal to 0. If they said it's a factor, I'm saying if they said it's a factor, you're going to say f of 2 is equal to 0. Because of what? The remainder is what? The remainder is 0. But in our case, it's not a factor, this one. So we cannot equate to 0. There is a remainder. What is our remainder? Our remainder is 15. So f of 2, what does it mean from our functions? F of, if you're given f of 1, it means wherever you see x, put a 1. In our case, f of 2, it means wherever you see x, put a 2. Wherever you see this x, put a 2. So it's like this. 2 to the exponent of 3 plus px squared. So this is 2 squared. Wherever we see x, p is the one that we need. So there's no substitute there. Minus x. Our x is what? Our x is 2, remember? All right. plus what? Plus 3. There is a plus 3 there. Plus 3. All right. So this is f of what? F of 2. This is what it means. F of 2. Wherever x is, put 2. If it was f of 1, you put 1. So we are saying f of 2 is equal to what? To the remainder. What is our remainder? It is equal. The f of 2, if you substitute it here, this one, this is our f of 2. It is equal to what? The remainder, which is what? Which is 15. So we must take it as an equation now. It is equal to what? It is equal to 15 as an equation. You formed an equation that you need to solve for p, just like that. Guys, just like that. This is an equation. Simplify these values. 2 to the exponent of 3. This is what? This is 8. 2 to the exponent of 2, it's 4. 4 times p, or p times 4. It's what? It's 4p. You can just write it as 4p. So this is 4p. This is minus times 2, which is minus 2, plus 3 is equal to 15. So let's collect the like terms, guys. As we can see, from the left-hand side, we've got like terms there. There's 8 minus 2 plus 3. All right. So this was going to give us what? 9. So if you take these numbers, add these numbers, combine these numbers together, you're going to get a 9. So that's 9 plus 4p. 9 plus 4p is equal to 15. This is a linear equation, guys. Nothing complicated here. So take the 9 to the other side, or subtract 9 both sides. Subtract 9 both sides. So this will cancel. You remain with what? Positive 4p, which is equal to 15 minus 9. That's a 6. So you can find p by dividing by what? By 4. Since this is a multiplication, so you can easily divide by 4, just like that. So p is equal to what? Divide by 4. On your calculator, guys, 6 over 4. Just use your calculator. Get there. 6 over 4. That's 3 over 2. 3 over 2, or 1,5. Or you can have it like this, 1.5. It's up to you, guys. Up to you. It's up to you. 1,5. Anyone. So that is it. This is the value of p. For us to have a remainder of 15, the one that you are given there, we must have our p as what? As 2 over 3. Just like that. All right. On another part, we are given to simplify on question 2. Simplify the following. That's 2.1. Simplify these. So this is what you're given, guys. This is 4. This is 10. This is 5. All right. Just gonna take it aside, guys. I'm not gonna make the mistake like the previous time. I'm just gonna take it properly. That's 2.1. So it was the fourth root of. All right. So this was the fourth root of x squared minus 2xy plus y squared, like this, times what? Times this x squared minus y squared to the exponent of 2 over 5. X squared minus y squared to the exponent of 3 over 5. Not 2 over 5, but 3 over 5. All right. I do not want to make that mistake, guys. So this is 3 over 5. Everything like this, it's over what? It was the 10th root. 10th cube root. We've got cube root. We've got fourth root. We also have the 10th root. So this is the 10th root of what? Of x minus y, like this. All right, which was being multiplied to the 5th root. So it was the 5th root, like this. Then we are given x plus y to the exponent of what? Negative 2. So this is it, guys. Simplify. So here there's nothing. Don't be scared, guys, by these algebraic expressions. We are big, guys. If you check properly here, factorization, this and that. Factorization, expanding, this and that. All the algebraic knowledge that we understand in your factorization, also your exponent, as we do understand our exponents. So it's unfortunate that we do not have the laws of exponents in our simplification. All right, I wanted you to see this, guys, the way that I'm showing there is something else. All right, where is our formula sheet here? So I wanted you to see something. You just have this part of the logarithms here, the logarithms. You do not have laws of exponency. So that is the unfortunate part of your exponents, is that you do not have the laws, you just have the part of the logarithms. So as for exponents, you are the one, guys, you are the one who is supposed to know your laws, know them by head. Okay? So let's try to figure out some of the exponents that can be applicable where we have got the root and this and that, guys. Okay, this is just like the wall of this bracket, like this, is to the exponent of what? To the exponent of 1. So it follows that when x is raised to the exponent of 1 over n, 1 over n, it means we have the nth root of what? Of x. This is the nth root of x. It was to the exponent of 1. So it's just x there. The nth root of what? Of x. X to the exponent of m over n. M over n. There is a letter. There's another number there, which is 2, which is 3. So this means we are going to have the nth root of x to the exponent of this m, to the exponent of m, like this. The nth root of x to the exponent of, that is what it means. So we can have a reverse, guys, from this side going this side. We can have a reverse. So if we are to use this part, guys, we can see that each and every part here has got an x. Yeah, this is to the exponent of 1 if the exponent is not given. So let's start by that one. Let's start by that one of just removing this. So this one is the 4th root. It's just like the nth root of x. It means it was 1 over n. The whole of this part here, you take it as it is. X squared minus 2xy like this plus y squared as it is. The whole of this part is raised to the exponent of what? 1 over 4. The 4th root. Exponent of 1 over 4. Times, all right, this one is already raised to its exponent. The factorization, I'm not talking about it now. Going to apply it later on. This time, we just need to get rid of these, the root signs, the 10th root, this and that. So as for factorization, we'll talk about it at once. All right, so this is it. Everything like this is affected. The 10th root of this to the exponent of what? Of 1. It simply means x to the exponent of 1 over n. So that means we have got x minus y like this to the exponent of 1 over 10. 1 over the number that is inside of what? The root sign. 1 over 10. That is our case. Times, this is the 5th root, but take note, it is raised to the exponent of minus 2. When we have an exponent here, m, it will be what? M over n, m over n. So m over n minus 2 over 5, minus 2 over 5. So it means we have got x plus y like this to the exponent of minus 2 over 5. Minus 2 over what? 5. This is the same application here. 1 over 10. 1 over what? Over 4. That is the same application. So this is where we are. We managed to get rid of these roots that we had and exponents. Factorize where possible. Let us try to factorize in this case. All right, so this one, guys, is a direct factorization. If you still remember our a squared minus b squared. Guys, even if it is given in terms of x and y, it is the same thing. This is our a minus b. This one. Are we seeing, guys, our a squared, our a minus b squared? This is exactly what we have. A squared minus 2ab plus what? Plus b squared. This is exactly what we have. X squared minus 2xy plus y squared. So it was taken from where? X minus y. Take note, there's a negative here. So this whole part that we see there, it was taken from x minus y squared. Guys, from question number 1, we have been talking about this. You see, they need you to know that. They need you to know these identities. So this is simply x minus y squared. But raised to the exponent of what? Take note, there's an exponent which is already there of 1 over 4. How do we expand? Remember, an exponent to an exponent. So you raise this to the exponent of what? 1 over 4. There's an exponent already which was there. We factorized this. This is your factorization. We move on this difference of two squares. Exactly our difference of two squares, guys. Are they supposed to write a squared minus b squared so that you understand its difference of two squares? No. They can use any letter, m squared minus n squared. If you understand a squared minus b squared, therefore understand this, guys. It's a difference of two squares. So meaning to say, we are going to have two brackets there. F of what? X minus y into x plus y. This is what we have. But the whole part was being raised to the exponent of what? 3 over 5. So it simply means also the whole of these two brackets will be raised to the exponent of what? Of 3 over 5. Do not forget your exponents. In the denominator, already these are in simplest form. There's no need for us to factorize x minus y. So you're just going to rewrite x minus y to the exponent of what? 1 over 10 times this one. We're just going to rewrite x plus y to the exponent of what? Negative 2 over 5, like that. So let's apply our laws of exponents where they are applicable. Like on this part, we have an exponent to an exponent. So remember our laws of exponents. We can multiply the x to the exponent of a. Let me just use m and n, the one that I've been using, to the exponent of n. You simply multiply m and n together, m times n. So here we're going to simply multiply 2 times what? 2 times 1 over 4. From your calculator, that's 1 over 2. So it was going to give us x minus y. The whole of this part, we multiplied, guys, 2 and 1 over 4. We multiplied them together, gave us what? Gave us 1 over 2. Times, what are we going to do here? There are two brackets raised to the exponent of 3 over 5. What does it mean? A, b to the exponent of m. Every part will be raised to the exponent of m. It will be a to the exponent of m, b to the exponent of m. A product. So it means this will be raised to the exponent of 3 over 5. This will also be raised to the exponent of 3 over 5 from that understanding. So we are going to have, x minus y to the exponent of what? 3 over 5. Times this part. So it's all already under multiplication. So you can even put a multiplication there. X plus what? X plus y to the exponent of, again, 3 over 5. They will take the same exponent, m, just like what we had here. All right? Guys, know your laws of exponents. This part, just rewrite. We do not have any law. We cannot combine anything. They just rewrite as it is to the exponent of 1 over 10 times x plus y to the exponent of minus 2 over 5. So this is where we are. What are we going to do? Our laws again. Multiplication, division, x to the exponent of m times x to the exponent of n. We add the exponents when you are multiplying the bases that are the same. A division, if you are dividing like this, you subtract the exponents. So you need to consider where we have the same bracket, like this part of x minus y. Where do we have any part of x minus y? There is here x minus y. There is also this x minus y. So considering that part of x minus y, what is happening, guys? Let's analyze. On top here, it's a product. These two brackets here, it's a product. This part here, you are multiplying. So when you are multiplying, what is that you do? You add. So it was going to be x minus y like this. You add these exponents. 1 over 2 plus 3 over 5. These are your exponents. But there is also this x minus y in the denominator, this one. So what are we going to do with it? A division. You subtract. Whenever you divide, you subtract. So you're going to subtract this exponent, 1 over 10. So you're going to subtract 1 over 10, just like that. You move on to the bracket of x plus y. There is a bracket of x plus y, as you can see here. There is x plus y. We also have the x plus y. What is happening between these two? They are under a division. So division, you subtract. So you're going to take x plus y, which is on the numerator, this one as it is. You subtract. What are you going to subtract? This one, it's minus 2 over 5. Already it is carrying a negative on its own. It is carrying a negative on its own. So this is the minus of the law. The law is saying you must subtract. What are you subtracting? It is carrying a negative on its own. So you are not supposed to ignore that negative because it's already there. You put that negative, then you can simplify, guys, as we do understand our numbers. So here, just use your calculator. 1 over 2 plus 3 over, it was going to give us a 1. So this one was going to give us a 1. So it was going to be x minus y to the exponent of 1 times. You also do the same thing here, simplify. Minus and minus was going to be a plus, so it was going to also give us a 1 there. That's x plus y to the exponent of 1. Remember, any number to the exponent of 1, it remains as it is. So when you raise to the exponent of 1, there is no effect. These two brackets will just remain as they are. There's no effect for expansion or, for raising a number to the exponent of 1. There's no effect at all. So this is what you have at the end. The difference of two squares there that we see. So guys, this is it. This is what we needed. So we must show each stage. This stage. From that stage, go to this stage. From that stage, we are now at this final stage of it's all about the laws. Each and every stage, it's about the laws. Unless maybe you're just talking about these factorizations. And those factorization, again, you need to know your algebraic identities. You see, guys, knowing those simple, they'll be like simple algebraic expressions, but those guys, they are very, very important. Very, very important. All right, 2.2 for 8 marks. Let's see what you're given there. Solve for x, given the logarithm of x in base of 3 plus 2 is equal to the logarithm of 27 over the logarithm of x, like this. All right, so guys, this was a weird type of a question that we just needed to figure out what is happening here. There is log x base 3. Look properly here. And there is log 27, then there is log x. Guys, these two are different. Log 27, it's on its own. Log x, it's on its own. So it means it's in the base of 10. These two cannot be, this is log x in base of 3. This is log x in base of 10. So these two, they are not the same. So you cannot even think of getting of the denominator to say, let's get rid of the denominator, multiply by log x by log. We are complicating because when you multiply these two, it will be like this, log x base 3 times log x, which is in base 10. These two cannot be multiplied. We do not have a law that can multiply these two because the bases, guys, they are definitely different. Even if the bases are the same, you cannot multiply. The only thing that you can do is that maybe you're multiplying log x base 3 like this. Maybe you're multiplying log x times like this, log x base 3 times log x base 3. You can simply just write it as a square. This one, you cannot, there's no law again, but you can just write it like what? Log x base 3 what? Squared. At least it's something that can be written in a simpler part. So guys, we need that. Log 3 again, this one. Log x base 3, this one. We need it. How are we going to have this? So this is going to be our reference because it is clear We can create a log x base 3, guys. How are we going to create it? Let's figure out these numbers. They just wanted to hide something here. Log 27 base, log 27 over log x. They wanted to hide something. What is it that they wanted to hide? In our logarithms, all right, just gonna take you to the formula sheet again. All right, so that will be together here. In our logarithms, you see this law, it changes a log which is under a division, log A base C, log B base C. Like just this one, the C is simply showing you that it's the same base C. So log A over log B, log A on its own over log B on its own, it gives us log A base B. As long these two bases are the same, it gives us what? Log A base B. Log of what is on top, the base of what? This one, the one that is in the denominator. So guys, understanding that law, we're going to change that log 27 into a base, this one, log 27 and log x, because of this law. So you understand that log A base B can be taken from what? From log A over what? Over log B, provided that the same bases. So here we're in the base of 10. We're in the base of 10, guys. This is the same base. So it means we are going to have log x base 3 plus 2 is equal to the logarithm of 27 in the base of x. Log A over log B, log A base B, log this base this. So the denominator, this one, it becomes your base. The number that is in the denominator there. So it simply means, guys, log 8 over log 2 is the same as log 8 in the base of 2, like this. Use your calculator to simplify this. You'll see that is the same answer. So this is where we are. But still, we do not have this. And the possibility of having this can be there because of what? The 27. Remember, 27 can be written in the base of 3. So you can have that as 3 to the exponent of 3. So it will be log x base 3 plus 2 is equal to log 27, guys. This one is the same as log 27 as a number is 3 to the exponent of 3. So remember, from our laws of logarithms, guys, we can drop that exponent if you are given an exponent on your log here. Let's go back to our formula sheet here. Log A, when raised to the exponent of m, the m, which is the exponent, multiplies the log, m log, if it is an exponent. So if it is multiplying, you take it there to be an exponent. That is the case of our law. So in our case, it is an exponent. So we are going to drop that exponent, this one. Is it the part that I was explaining? Is it the part here? Yes, exactly. Yeah, we drop this exponent. So it's going to be 3 log 3 base x, like this. So this is the same thing. You drop this exponent, you drop it. So it's 3 log. So this is what we have. In place of this log 27 base x, it is the same as 3, the logarithm of 3 in base of x. Take note. Take note. Guys, you must be very careful. But it's still not the same thing, guys. All right? It's still not the same thing. These two, they are still different. This is log x base 3. But this one is what? Log 3 base x. These two, they are different. But remember, we want to have it, this one. Log. Remember, I said I'm going to use this as the reference. So let me mark my reference. So remember, this is my reference. So I want to change this to look like this. Is it possible for a log 3 in base of x to be written as log x base 3? Is it possible? Yes, it's possible. From which law? There is a law which changes the base automatically. log A in base of B. If we want to change this, these two, if we want to interchange this, we introduce 1 over. The moment you have this 1 over, look, take a look, this one, they've interchanged. It's now log B base what? Log B base A. Examples are log X base 3 can be changed. Examples are log 3 base X, it can be changed. The moment you introduce 1 over, this one, 1 over, you interchange. So this is the law that we are going to take. With this law, guys, we can change that log to look the same way as another one from that law. Log A in base of B can be changed the moment you write as 1 over. You interchange these. So it will be what? It will be log B in base of A. In base of A. You interchange this. Remember, it was log A base B. So it will be 1 over log B base A. The moment you introduce this 1 over. So as we want to change this one into this, so we can introduce the 1 over here. So it means we are going to have log X base 3 plus 2 is equal to 3 times, take note, guys, we want to change this one. The 3 is not affected. This one, 3 is just a multiplication. Is just like 3x, 3 times x. So the 3 is on its own. We are focusing on the log here, the one that we want to change. This one. This is the part that we want to change. Log x base, log 3 base x. So how can we change it? The moment we introduce this 1 over this one. So it will be 1 over. The moment, guys, we are saying these two, they are equal, guys. Don't confuse mathematics. They are the same. There is no effect at all. Only that you have changed. So it will be log what? We interchange. It was A base B. Now B base A. So it will be what? X base 3. You interchange this. It was X base 3. So it will be X. It was 3 base X. This one. 3 base X. 3 base X. So interchange X base 3. 1 over. Just like that. Just like that. So as we can see, these two, they are exactly the same. This is what we just needed to have this, our reference, this one, to have this and this exactly the same, this one, in the denominator, this one. As you can see, they're exactly the same. Another one is properly written. Another one is on a fraction. So get rid of those fractions, guys. Now, as long as you've got these two being the same, you're done. Get rid of the fractions. How do you get rid of the fractions, guys? You must multiply every term by what? The LCM or your LCD. Take note, these are numbers. This is same as over 1. This is same as over 1. This 3 years is part of this log, guys. It's one thing, this one. So you multiply by the LCD of 1, and log x base 3, which is what? Log x base 3. Remove the fractions. So you're going to multiply by the logarithm of x base 3. Here, we multiply each and every term. Log x base 3. Here, we multiply log x base 3. Each and every term. So this was going to cancel. We are back to that part that I was explaining. The logarithms that are the same when being multiplied. We do not have a law there. But we can simply combine them like this. Log x base 3 squared. The whole of this part is being squared. That's how you can just write them. Otherwise, there's no law there. So you can just write log x base 3 squared plus what? That was the reason of actually having the same log, so that at least we can combine it like this. Here you multiply 2 times log x base 3. So that's 2 log x base 3 is equal to, remember here you cancel this, you're left with 3 times 1, which is 3. So that is it. You have formed an equation under logarithms, which is a quadratic equation because of the highest exponent. It's a quadratic equation under logarithms, this one. Logarithms, they also have quadratic equations. So remember the format of a quadratic equation. One of the side must be equal to 0. So you're going to have log x base of 3 squared plus this 2 the logarithm of x base 3, you take the 3 to the other side. So it will be what? It will be a negative 3. So take note, this is a single part of log x base 3. So understanding your logarithms, you can factorize, guys. Your equations. You can factorize this. Or you can introduce a constant, any letter that you want in place of the log x base 3. As you can see, it's the same. So we can even let k be equal to the logarithm of x base 3. It means wherever we see this logarithm of x in base of 3, we are going to put what? A k. So our equation is going to be what? K squared. This is now k. Plus this is now k. So this is 2k minus 3 is equal to 0. We have an equation, quadratic, a factorization method, whatever that you are capable of, solve for k. Solve for what? For k. So in this case, I'm going to use factorization method, guys. The coefficient of k squared there is 1. So I'm simply going to have my 2 brackets. This is k. This is k, considering the constant, which is minus 3. What are the factors of negative 3? But these factors must add up to what? To 2, positive 2. Factors of negative 3, 2 numbers. You multiply 2 numbers, you get negative 3. So definitely there's 3 and 1 there. 3 and 1, is it negative 3 and 1? Or is it 3 and negative 1? If you multiply this, you get negative 3. If you add, you get what? Negative 2. You multiply this, you get negative 3. But if you add, you're going to get a positive 2. So this is exactly what we want, where we have got what? A positive 2 at the end. So it was 3 and what? Negative 1 plus 3 minus 1. So solve for k, guys. The 3 to the other side was going to give us what? A negative 3. Or our k is equal to what? The minus 1 to the other side was going to be what? A positive 1. So these are the values of k, not x. Our equation was not having k. It was having x. Originally here, there was x. So we are solving for x. Whatever that we are solving there represents x, not k. It is us who introduced the k here. It was introduced. We introduced something here that was not part of our equation. That is why we write let k be this. So as we need x, let's bring back what we introduced. What we substituted back, that part of log x. So we bring back that. So what does it mean? It means from this part, 2 representing, our k there, our k, from that k, which is equal to log x base 3. So it means the first k is what? Negative 3. So we are going to take that log as it is. The logarithm of x in base of 3 is equal to, what is our k? The first k is minus 3. Or we take this part equated to the what? To the logarithm of x in base 3. So it is equal to what? It is equal to 1. So just like that. So we can solve. Remember, our logarithms again changing from a log to an exponential and vice versa. If you are given the logarithm of a in base of b is equal to c, remember I said that this a is equal to b to the exponent of c. It's a conversion which is done from one format to another, from log to exponential or from exponential to log. So this a is equal to b to the exponent of c. So that's b to the exponent of c. So in this case, this is our a, this is our b, this is our c. So what does it mean? Our a, which is what? X. X is equal to b to the exponent of c, the base to the exponent of the answer, 3 to the exponent of minus 3. So that's it, guys. On your calculator, you're going to get 1 over 27. Or you do the same thing here. You take this x, that is our a. So x is equal to 3 to the exponent of what? 3 to the exponent of 1. So that is 3. 3 to the exponent of 1 is what? Is 3. So these are the possible values of x that you're going to have. And we can even test these values as we can see from our logarithm here. X is also on the base. Here it's on, sorry, it's just a number. It's just a number here. So if it is given on a number like that, the logarithm cannot be, the logarithm of a negative cannot be evaluated. So in our case, all these numbers, they are positive. So logarithm of positive numbers, they do exist. We can find the logarithm of a positive number, not of a negative. You can't find log -5 like this. You can't evaluate that. That is what I'm trying to say. But if it is a positive, then it's possible. So these are the possible values. All right. So if you substitute them back, it still remains as a positive. So there is no effect at all. So that was it for 8 marks. Okay, that was it. Okay, anyways, another 7 marks there. Question number 3. 3.1, we are given the area of a rectangle. So the moment you're given this is word problem, guys. This is just a word problem. So it's a rectangle that you're given. And we are told that its area is 5 square meters. Remember, area was taken from length times what? Length times width, or length times breadth. Its perimeter is equal to what? Is equal to 9 meters. Remember, perimeter was taken into 2, length plus what? Length plus breadth, or length plus width, depending with whatever that you're using. So they are saying determine the dimensions of the rectangle. So guys, a rectangle, let's say this is our length and this is our breadth. So guys, how did you find the area? Length times breadth is equal to this. So it's just like forming equations, guys. 2 equations that we are going to form there. From the area, length times breadth is equal to what? Is equal to the area, which is 5 as we are given. It's an equation. I call it equation 1. From equation 2, this formula of 2 into length plus breadth as it is equal to what? It is equal to 9. That's our equation 2, of which you can even expand these brackets. So it will be 2L plus 2B is equal to 9. You can even divide by 2, like everything. So this is what? Our equation 2. So we've got 2 equations there. So these are simultaneous equations. So how can I solve for L and B? I can play around with this change of subject. From equation 1, I can make L the subject. I can make B the subject. It's up to you. So from equation 1, it's up to you guys. Which one do you want to make the subject? It is easier for us to make any. So here I'm going to make L the subject from equation 1. Make L the subject. So if I am to make L the subject, what does it mean? I'm simply going to divide by B. Remember, LB is equal to 5. So I'm simply going to divide by B like this. So that's our L. So L is equal to 5 over B. And we're going to call this what? Equation 3. Remember, 1, 2. So this is now our equation 3. We made the subject from equation 1. So whatever that we obtained, which is our equation 3, we are supposed to substitute this equation 3 into what? Into equation 2. So you substitute this into equation 2. So let's substitute, guys, and see what's going to happen. In place of L, put this 5 over B. So that's 2 times L, 2 times 5 over B plus 2B is equal to 9. 2 times 5 over B is like this. 2 times 5 over B. 2 is a whole number, so it's like 2 over 1. So how do you multiply? Is 2 times 5, numerator to numerator, denominator to denominator. Not 2 times 5, 2 times B. No. You multiply numerator to numerator, denominator to what? Denominator. So it was going to be 10 over B. So that's it. 10 over B plus 2B is equivalent to 9. So that's an equation, and there is a fraction. So you're going to get rid of the fraction because this is same as over 1 over 1. So the LCM of B, 1 and 1 is what? Is B. So you multiply each and every term by the LCM, by B here, by B here, by b here, each and every term by the LCM. So that was gonna b and b cancel. You got a 10 plus 2b times b, that was gonna be 2b squared. Here, 2b times b, that's 2b squared, is equal to 9 times b, which is 9b. So looking into this, we can see that's a quadratic. We have a quadratic equation. The highest power, highest exponent is what? Is 2. So remember the format of your quadratic equation. Ax squared plus bx plus c is equal to 0. One side must be equal to 0. So you're going to take this to the other side. So it was going to be 2b squared. The 9b to the other side will be what? Negative 9b plus the 10 that we are seeing here. It is equal to 0. You solve this equation that you're having by factorization, by what, guys? By the quadratic formula. It's in your hands now. This is your quadratic equation. So we have been using the quadratic formula, guys. A lot of times I just want to talk about factorization, but you guys, you can even use quadratic formula, no problem. But remember your factorization. There's this factorization, guys, which we can refer to. I want you to see something. Factorization also, the way that you understand, guys, here we just need 2 brackets here. There's also this method, if you understand, it's fine, which is the cheat method. If you consider, check factorization for mathematics grade 11. I talked about that method, which can be used to factorize these quadratic expressions by this cheat method. So I'm just going to explain the basics with this example, but you just see, guys, if you go through those videos there, they are very easy. So this is it. We are used when the coefficient of x squared is 1. In this case, we're talking about b. We are used with this as 1. In this case, it's 2, not 1. So that's why we need to use this method. So we get rid of the 2, you multiply it to the last term. All right? So it will be b squared. You get rid, you remove it totally. Remove it total, you multiply it there. So it will be b squared minus 9b. Remember, we removed that one, you multiplied it here. So it's 10 times 2, which is what? Which is now 20. So that's plus 20. Now, the coefficient of b squared, if you check, it's 1 this time. We are used to this when it is 1. So we can factorize because we are used to this, where we can have what? Our 2 brackets. Remember, this is b, this is b. Then you ask yourself the factors of what? Of 20 that you add up to give what? Negative 9. This is what you are used to. So you can see that 5 and what? 5 and 4 there. But for us to have a negative 9, negative 5, negative what? 4. So these are the numbers that we're going to use there. Negative 5 and what? And negative 4. So guys, never be tempted. This is not our answer because it is of this, not of this one. There we are to cheat so that we have this as a 1 from the 2b squared that we had. So we bring back that 2 that we removed. So we have to bring it back. So there's another way that if you can understand, then you can use it. If you don't, use any other way that you understand, guys. All right. So you bring back the 2. Where the b is, you bring back the 2. Only where b is. Remember, it was on b squared. So this is b times b, which is b squared. So you remember that the 2 and the 2. Where possible, factorize in these 2 brackets. Where possible, what? Factorize. The first bracket, nothing is common. So it's going to be 2b minus 5. All right. Minus 5. The second bracket, this one is 2b minus 5 like this. The second bracket, 2 is common. 2b minus 4. 2 is common. So I can factor out 2. I will remain with what? 2b divided by 2, that's b minus 4, and 2 will be minus 2. The number that you factored out becomes useless, this one. You get rid of it. It's no longer part of your question. You do not even need it. So these are the 2 brackets that you need from here. 2b minus 5 into what? Into b minus 2. So guys, here I said use any method that you understand. Any factorization, guys, is in your hands. You can even use the quadratic formula to what? To solve. It's in your hands there. But after this, you can solve one of these brackets must be equal to 0. So 2b minus 5 must be equal to 0, or b minus 2 is equal to 0. So let's solve for b. The minus 5 will be what? Positive. On the other hand, then you have to divide by what? It will be like this. 2b is equal to 5. So you have to divide by what? By 2 by 2. So it will be 2 over 5. Or b is equal to the negative 2 to the other side. It will be what? It will be a positive 2. Just like that. So b can be 5 over 2 or 2. 5 over 2 is 2,5, guys, as a decimal. So remember, b is the breadth, and the breadth is smaller than the width. If you're considering the breadth, it is smaller than the length. I mean, the breadth is our width. It is smaller than what? The length. The width is smaller than the length. That is what I'm trying to say. So comparing these two values, which one can be our b? The smaller one. You have to take the smaller one, this one. Okay, so in this case, therefore, you're going to take our b to be 2 meters. The breadth is going to be 2 meters. Then the length is going to be the other one. But if you do not understand it, guys, for this type of equation, substitute it back here. Remember, length is equal to what? 5b. We already made that one the subject. Our length is equal to what? 5b. So if our length is equal to 5b, then substitute the value of b that you have. 5 over b, our b is 2. So therefore, our length was going to be what? 2,5. So this is it. These are the dimensions of the rectangle. The length, 2,5. The breadth, 2 meters. So if you use these conditions that you are told that the area is 5, it's supposed to give us the same thing, guys. If this is 2,5 meters and this is 2 meters, length times width, if you multiply 2,5 times 2, is what? It's 5. If you add the perimeter there, distance right round, or use this formula, you must find what? 9. That is the case of our question. So where the problems, guys? Play around. It's a play around the type of equation. So you form your equation. Look into the equation. What type of an equation have you formed? Is it quadratic? Are they simultaneous? Is it just a linear equation? You must study the type of equations that you're going to have. Then you solve from there. So in our case, they were simultaneous. So we had to solve for two values at the same time. All right, no problem, guys. Make X the subject on this one, this type of equation, guys. Now I don't know how many times are they repeating this type of equation. It's just a repetition, guys. The layout, everything, just that they change the numbers. All right, no problem, guys. Remember, we have got E, the exponential. So you can introduce the ln, but before introducing the ln, get rid of this number. They just want to confuse you because of this number. They can even put a letter here in place of this number. They can even put letter R, they can put letter D, they can put whatever they want. So it's a product there. Simply remove that 5 by what? Dividing. Divide by 5, divide by 5 like this. So it means A over 5 is equal to E to the exponent of 5 over what? 5 over X. Where E is this one. You introduce the ln, the logarithm, the Neperian log, ln both sides. Knowing that ln operates as a log. So once that ln is introduced, we can drop the exponent. That's how you simplify. So this will be ln A over 5. You can even just open a bracket for this one is equal to, you drop this exponent here to multiply the ln. Take note, guys. So it will be 5 over x, the ln of what? E, where we understand that from our logarithms, ln of E is equal to what? Is equal to 1. So meaning to say, we are left with ln A over 5 is equal to 5 over x times 1 is what? 5 over x. So guys, this is just like a whole number where it is given like over 1 like this, where cross multiplication is also necessary to remove these fractions. So it will be x times this ln, the whole of that part of ln, multiplied to what? To x. So it's x, the ln of A over 5 is equal to 1 times 5, which is 5. Remember, we want to solve for x. We want to make x the subject. So what are you going to do? The ln A over 5, simply divide by it. Divide by ln A over 5. both sides. It's an equation. Whatever that you do on the left-hand side must be done on the right-hand side. So this was going to cancel. Just like that. So this is your x. So x is equal to 5 over this. So our x is equal to 5 over ln A over what? Ln A over 5. Is it a 5 there? Yes, just like that. Or you can even use the laws. Remember, division of numbers there, it simply means you are what? Subtracting the logarithm. So it's ln A minus ln 5 like this. So you can even write it that way. X is equal to this. It's in your hands. These equations, they are in your hands. Can play around the way that you want. So let's communicate on the comment section, guys. What is that you think about solving these typical equations? Question number 4, you're given below. Here on this fig 1, it shows points P, Q as vertices of triangle PQR. So it's a triangle, this one, all right? That's PQR, okay? Then we've got beta is the angle of inclination of PQ, this line PQ, and as you can see, our beta there, the angle of inclination between the x-axis and the line, which is exactly true. All right, so this is exactly true. Very true. Let us consider our questions. 4.1, determine the coordinates of the midpoint of the line segment PR. The midpoint PR, the line segment PR, the midpoint as we have. So this one, guys, even if you've forgotten these guys, here you're not supposed to even leave this type of equation. The formula sheet have already listed all, almost all, not all, but almost about a straight line. And these are the part of your from perpendicular lines, relationship of parallel lines, the distance, the midpoint, the angle of inclination. It has been listed. So as we are giving the midpoint, so we are here, we have to add x values, divide by 2. We add the y values, we divide by 2, just like that. That is the meaning of the formula. You add the x values together, divide by 2. So we need the midpoint of what? Midpoint of PR, right? So that's 4.1. So the midpoint of line PR is just going to be x1 plus x2. Just add the part of x, guys, over 2, then the part of y there over 2, just like that. So it was going to be, this is PR. So this is xy, guys. Remember your point xy. So x1, y1, x2, y2. So just add 2 and what? And 5. 2 plus 5 over 2. The y values 3 and what? Minus 3. So that's for the y values 3 plus minus 3 like this over what? Over 2. Just like that. So you're going to have the midpoint of what? Of this line PR, which is 2 plus 5 over 2. That's 7 over 2. 3 plus minus 3. That's 0 there over 2. That's a 0. So that's it. So that's our midpoint, which is actually at this point because y is equal to 0. So we are very sure that it is this point. So that's point 7 over 2, 0, which is the midpoint of what? Of PR. This is the point. 7 over 2, 0. Just like that, guys. So this one was just going to be direct. Just going to be direct. Then 4.2, the gradient of the line segment PR. Same line, but this time we need its gradient. So how do you determine the gradient of a line? That's 4.2. So the gradient of the line PR, remember the gradient is change in y over change in x. y2 minus y1 over x2 minus x1. So for PR, y2 minus y1, y2 minus 3 minus 3. You subtract the 3 there. So it's minus 3 over what? x2 minus x1. Our x2 is 5 minus our x1 is 2. So that was going to be minus 6 over 3. Yeah, which is minus 2. So that's our gradient there. Minus 2. So the gradient of the line PR was going to be what? Negative 2. The size of beta, the angle of inclination of what? PQ. size of beta, the angle of inclination, guys, we saw it properly from our formula sheet. Theta, the angle of inclination is what? Arctan. Arctan M. M represents what? The gradient. So it's arctan, the gradient. Arctan, the gradient. Meaning to say, you must have the gradient first. Do we have the gradient of PQ? No. So we must find the gradient of what? PQ first. All right. So that's 4.3. So to find beta, the angle of inclination of between the line PQ, we must find the gradient first of this line PQ. Just like the previous case, guys, the gradient of PQ is so change in y over the change in x. So this is y minus y there. That's 0 there for the y value, minus the y value there, which is 3, over the x value there is minus 1, minus this x value there, which is 2, just like that. So that was going to be minus 3 over minus 3, which is 1. So this is the gradient M, the gradient of PQ. So how do you find the angle of inclination, which is our beta? From our formula, we saw that beta is equal to what? Arctan of the gradient, arctan M. The angle of inclination is arctan. Arctan what? The gradient. What is our gradient? The gradient of what? Of PQ. We're talking about the gradient of PQ there. So meaning to say our beta is simply going to be arctan of what? Arctan of 1. That's our beta. And what is arctan of 1 from our calculator, guys? This is what? 45 degrees. So this is the angle beta that we are seeing there. That's 45 degrees. All right. So just like that. So we have got this gradient, this and that. Then PQ, its length, the length of the line segment PQ in the simplest said form, in said form, PQ, same PQ that we have here, but now we need the distance, the length between, remember from your distance formula, guys. All right. So that's our 4.4. You're also given your distance formula from your formula sheet. So the distance between 2 points is given by the formula. That's x2 minus x1 squared plus y2 minus y1 squared. Simply subtract x values, subtract y values, x2 minus x1. PQ. X values minus 1 is going to subtract what? 2 for the x. So that's the square root minus 1 minus 2 squared. Plus, you move on to the y values, y there. So that's 0 and what? 3. So that's 0 minus 3 squared. Just like that, you can even use your calculator, guys. Minus 1 minus 2 squared is minus 3 squared, which is 9. This one is also minus 3 squared, which is 9. Add this, 9 plus 9 is 18. Square root of 9, guys. Square root of 18, that's 3. Square root of 2. You can even use your calculator, guys. 9 times 2. 9 times 2 under the square root. Square root of 9 is 3. This one is, guys. All right, no problem. Just use your calculator, guys. This is just mathematics. Sometimes you can just play around in exam to say, okay, this one I actually know it by head. It can be like that. Or you can just use your calculator. The calculator is there. So also take that as an advantage that you have got your calculator. So this is the length of our line PQ. Remember, we calculated the gradient of this line PQ, guys. Do not forget in terms that we might need any of these values here. The gradient of PQ, it gave us 1. It was 1, positive 1. Okay, no problem. No problem. Let's see here. On question 4.5, here the equation of a line segment through P, which is perpendicular to QR. Leave your answer in the gradient intercept form y is equal to mx plus c. All right, we'll see this one later on. Let's start by this. It's through P, which is perpendicular to QR. Through P, through the point P like this. It is going to pass through this point P, but perpendicular to QR, perpendicular to this line, meaning to say, as the line is being drawn, as it meets this line, it will meet at what? 90 degrees. It will be perpendicular. They did not say it's a perpendicular bisector. No, they say just perpendicular. If they say perpendicular bisector, it means it will divide this line into two equal parts. But that is not our case. It will be just at 90 degrees. Please take note, guys. It will be just at 90 degrees. Only that. There is nothing important there. So what is the condition of knowing that this line is at 90 degrees? Remember, if the two lines are perpendicular, the product of their gradients is what? -1. You're also given this from your formula sheet, guys. Like I said, everything is given. For perpendicular lines, M1 times M2 is what? -1. Product of gradients. If they are parallel, they have same gradient. So in our case, we are talking of what? Perpendicular. They are perpendicular. So it means the gradient of the line that we need to calculate here, okay, that's 4.5. The gradient of the line that we need to calculate, which is going to pass here, times the gradient of the line that it is perpendicular to. This one, that it is perpendicular to, which is what? Which is QR. It is perpendicular to QR, remember? Or RQ, this QR. They must give us -1. So that is the case of our question. Are we having this gradient of QR? We calculated this before. Remember QR here? QR. We do not have. No, we do not have. We do not have. We never calculated this. We do not have this QR. It was PR. So we are forced to calculate this gradient first because we do not have the gradient of what? Of QR. Just like the previous case, guys, how you were calculating the other gradients. So the gradient of the line QR, the change in y over the change in x. Do not forget, guys, this is just a formula to use. So q to r, from q to r here, that means y2 is what? -3 minus y1, or y value x, y there, or y value is what? That's a 0 there, over x, x2, that's 5, minus x1, our x1 is what? -1. It is carrying a negative on its own. It is already carrying what? A negative. So this will be -3 over 6, which is what? Minus half, -1 over 2. So this is the gradient of what? QR. QR, it has a gradient of -half. This QR, this one. So it means the gradient of the line that we want times the gradient of QR that we calculated -half. It is supposed to give us what? -1. So what is the gradient of the line that we need to determine its equation? Simply divide. It's a product. Divide by what? By -half. It's a product, this one. So M is equal to what? Dividing this on our calculator, -1 divided to -half. That's a 2, a positive 2. So we can determine the equation of this line. So the part of being perpendicular here is the one that we have been working on, being perpendicular. Their gradients, if you multiply them, will give you -1. So you form an equation from there. So knowing that we have got a gradient, and this line, we are told the guys about this line, it passes through what? It passes through the line segment, through P. This line segment, it passes through P. So we have the point P again. We have a gradient and we also have a point, which is P. 2, 3. This is enough for us to have what? Equation of a line. The gradient and a point. This is enough, guys, for us to determine the equation of a line, since we understand that the equation of a line is given in the form of y is equal to mx plus c, where m is the gradient, and we have it as what? As 2 for this line, plus c. So to determine the value of c, substitute the point that you're given, xy. The point, you have it. X is 2, x is what? 2, y is 3. So you're going to substitute y is 3 when x is what? When x is 2. So that's it, just like that. 3 is equal to what? So 3 is equal to 2 times 2, which is 4 plus c. Take this 4 to the other side. It was going to be a minus, or just subtract 4 both sides. 3 minus 4 is equal to C. So C is what? -1. Just like that, having this C and this part is enough to us for us to have it as a final equation. So therefore, y is equal to what? Remember, we had 2x plus c. Our c is what? Our c is -1. So that is our equation of that line, which passes through P and being perpendicular to this line. Being perpendicular helped us on determining of the gradient. Then passing through P. It's a point that you must have now. So if they say it's a perpendicular, they will not even mention to say it is going to pass through this one. No, they don't mention if it is a perpendicular bisector. This one, it's not a perpendicular bisector, it's just perpendicular. So read your question carefully. All right. On question 4.5, the equation of a line passing through the point Q, it must pass through Q, pass through Q. This is where we have our Q. It must pass through this point. But not only that, and which is parallel to the y-axis. As it passes through this point Q, it must be parallel to the y-axis. Which lines that are parallel to the y-axis? How do we see a line parallel to the y-axis? This is a y-axis, guys, like this. This is a y-axis. These lines like this is parallel, vertical lines. So if a line passes through Q and parallel to the y-axis, it's like this. It's like this. That is passing through the point what? Q, parallel to the y-axis. So what will be the equation? The equation of the line that is parallel to the y-axis is given in the form of x is equal to, remember I talked about this type of lines, guys. X is equal to, what is the value of x there at Q? X is -1. So therefore our equation, x is equal to -1. This is the equation of the line, just like that. The value of x at that point. That is why you see the y-axis. What is the equation for the y-axis? X is equal to 0. All these lines at P, if it passes through P like this, x is equal to what? At P, x was 2. So x is equal to 2. If it passes through the point R there, what is the value of x there? X is 5. So it means your line will be x is equal to 5. As long it is parallel to the y-axis. So in our case, it was going to pass through the point Q. That's why we focus at that point Q, where we've got what? -1 on that part, where we have got a -1. Guys, it is important that you do your revisions carefully. On question number 5, you're given, draw the graph of this in the answer book. So guys, it's supposed to be in the answer book, and we do not even have a graph in the answer book. It's those lines. So what type of a graph is this one? Let's figure out the type of the graph that we have. 5.1 x squared is equal to 5 minus y into 5 plus y. It was something that they just wanted to complicate something here. 5 minus y, 5 plus y, guys. What is it? That's a difference of two squares. A squared minus b squared. Remember, it was taken from what? A minus b, a plus b. A minus b, a plus b. This is what we have. So these two, they were simply taken from what? 5 squared minus y squared. A squared minus b squared. So that's x squared is equal to 5 squared is what? Is 25 minus y squared. Is there any type of a graph like this that we know? No. But we know of a circle. When this is taken to the other side, it will be positive there. It will be like this. X squared plus y squared is equal to 25. This is exactly a circle. I talked about this, guys, equation of a circle. When it is like this, it means the center is what? 0, 0. And the radius from this 25, it's 5 what? Squared. So our radius will be what? 5, or the square root of 25. From the center 0, 0, your radius is 5. What does it mean, guys? Understanding that to say This is our Cartesian plane. Got X values, we've got our Y values like that. That's a 0 there. Understanding that the radius is right from the origin. This is the origin. This is your center here, the origin. So it means we are going 5 up. We are going 5 this side. We are going 5. So it simply means 5, 5, 5 around. Just draw your circle, guys. Remember, this is just a sketch. Draw your circle. So you're going to indicate a radius of 5 from here to here. It's 5 units. So that's a 5. This one, minus 5, because we are on the left side. Down here, minus 5 again. Okay. Up here, that's a positive 5. So that's a circle, this one. They gave us a circle in a disguised manner. That was in the disguised manner. It was a circle. Revise, guys. Do as many questions. Revise. On this curve that we are given in Fig 5.2, we have the curve of y is equal to ax cubed. And the point, this one, it lies on the curve. What does it mean? It is found on the curve. That is to lie on the curve. It is found. Determine the value of a, hence the equation. So it is easier, guys. We just have to substitute the point. Because it is found. It lies on this one. It is found. If I substitute x and y there into this equation, it satisfies our equation. So what is the value of y, guys? Y is 4. When x is what? When x is minus 2. So that's minus 2 cubed, x cubed. So 4 is equal to minus 2 cubed. That's minus 8. So minus 8 times a, which is minus 8a, divide by negative 8, divide by negative 8. That's it. So that was going to give us negative 1 over 2. Hence, the equation, you're supposed to write down the equation. Remember, so therefore, y is equal to what? We calculated a. Our a is minus half. So that's minus half x cubed. This is our equation, just like that. They just wanted you to, guys, you see, exam, guys. Exam answer, guys, exam is not a textbook, or it's not an in-class that your teacher can say, okay, this one, next time, do it like this. Exam, read to understand the question. Some of us, we have the mathematical view, mathematical concept, but we don't answer the questions in exam. We answer what we want to answer. No, guys, it's maths. Maths, you don't answer what you want. You answer what you are being asked in exam. What are they saying about the concept that you know? So it's all about the concept. So let's figure out the concept, guys. All right. In Fig 3 below, we're given the line. This is the line that we are given. So definitely, guys, we are given y minus 3x plus 6 is equal to 0. Remember, a straight line can also be written in the form of y is equal to mx plus c. The minus 3x to the other side there will be positive. The 6 will be a negative. You can even play around, do this, guys, just to know that you understand what you're doing. All right, no problem. So they're saying it is intersect the circle with the center at O. So if the circle has the center at O, it means its equation is given in the form of what? X squared plus y squared is equal to r squared. This is the format of a circle which is a radius what? Which is center 0, 0 and radius r. All right. At BD, these are the intercepts where they intersect the line and what? The circle. No problem. The x-intercept of a straight line is at A. This straight line, as we can see there, A, our x-intercept. Remember the conditions for the x-intercept. What are the conditions for the x-intercept? Y is supposed to be what? Equal to 0. If it is for the y-intercept, what are the conditions? X must be what? X must be 0. So that is it, guys. Just go through this. Determine 5.31, the equation of the circle. Already on the equation of the circle, guys, I know that I'm going to have x squared plus y squared. What is it that I need? I just need the radius. The radius is the only part that is limiting, because already we are told the center is 0, 0. And the radius is the distance from the center to the circle, from the center to the circle, from the center to the circle, from the center, any part. So as long we can find any of these distances from O to D, from O to this point, from O to A, which distance can we find? We can take advantage of B, because B is the intercept for both, is the intercept for the graphs. And it is also the y-intercept of the straight line, this one. It is the y-intercept for this straight line, where we understand that x is equal to what? X is equal to 0. So it simply means the y value at this point B here is minus 6. When x is what? When x is equal to 0. The y value there is minus 6. Guys, distance is like this. If you are going down, it's a minus 6. But it's 6 units going down. The number minus is just showing that you were going down. But when you talk of distance, you say, my radius is 6 units from this point going down. So this is our radius, guys. The distance here that we see here is 6 units. So therefore, the equation of the circle was going to be determined from this, because we understand it's given in this format. So therefore, we're going to have x squared plus y squared is equal to what? R squared, radius squared. What is our radius? 6. So that's 6 squared. So simplifying this, we're going to have what at the end? X squared plus y squared is equal to 6 squared, 36. For 2 marks, that's enough. The coordinates of A on 5.32, the coordinates of A, where they mentioned, specify that A is the x-intercept of the straight line. A represents what? X-intercept. And for the x-intercept, what are the conditions? What is the condition for the x-intercept? Y must be 0. Y must be 0. So you can substitute back even into the original equation here. Y here in place of y there. 0 minus 3x plus 6 is equal to 0. You solve for x. Y is 0. So minus 3x is equal to what? The 6 to the other side was going to be negative 6. It was a positive, so it's going to change. Divide by negative 3, negative 3. That's our x. So our x was going to be a positive 2. So therefore, the point A is what? 2, 0. Remember, point is made up of x and y. X is 2. What about y? Y is 0. Remember, those are the conditions that we substituted for the x-intercept, to say for the x-intercept, y is equal to 0. Just like that. Determine dy dx of this function. All right. Remember your derivatives. Derivatives, dy dx. You drop the exponent. You subtract 1 on the exponent. This is the basic view of your derivatives, guys. If you are given x to the exponent of n like that, you drop the exponent, then you subtract 1 on the exponent. It must be a number to a certain exponent, whatever that you have. So on our 5.4, we have got y, which is 3 square root of x. We must have x to the exponent of something there. So square root means what? To the exponent of a half. Plus, this is 4 over 3. This one, we can take the 4 over 3 on its own like this. So that's 4 over 3. What about what is remaining? If you remove that 4 over 3, what remains? It's 1 over x squared. 1 over x squared will remain, which is same as what? X to the exponent of minus 2. Right? So that's x to the exponent of negative 2. We are just rewriting so that we can differentiate. As long we have x raised to a certain power, x raised to a certain power, we can differentiate, guys. If it is ax like this to the exponent of n, the derivative of y with respect to x will be, you drop this exponent here, it multiplies, so it will be an x to the exponent of n minus 1. You drop the exponent, you subtract 1. So you're going to drop the exponent, then we subtract 1. So you drop that exponent. That's our derivative. That's dy dx. So it's 3 times what? 3 times 1 over 2. You drop it. So it will be 3 over 2 x to the exponent. You subtract 1. 1 over 2 minus 1. That's minus half. Okay? You do the same thing here. You drop your exponent, the negative 2, it multiplies here. Then you subtract 1 on the exponent. So that's negative times this one. So it was going to be negative 8 over 3 on your calculator. Negative 8 over 3 x to the exponent of what? Minus 2 minus 1. That's minus 3. So if you're to consider, they said, by means of the rules of differentiation, but they did not end there. They mentioned that the final answer must be with the positive exponents. Positive exponents. And in said form where applicable. So let's start with the positive exponents. X is carrying a negative. Take note here, guys. It means 3 over 2 times. This is what it means here. 3 over 2 is on its own. So it means 3 over 2 times 1 over x to the exponent of half. That is what it means. So if you understand this, you know that it will be 3 times 1, which is 3 over 2 times this. So it's 2x to the exponent of a half. Minus, here you do the same thing. This one, x to the exponent of minus 3. It's on its own, this one. It is on its own, this one. So it is just like we've got minus 8 over 3 times this one on its own. How do you get rid of a negative? 1 over x to the exponent of 3. So numerator to the numerator, guys, it will be minus 8 over what? The denominator to the denominator. So that's 3x to the exponent of what? Of 3. So we have positive exponents. The purpose here was having what? Positive exponents. Is there any part where we can have the said form where applicable to the exponent of a half? Guys, originally we had this half here to the exponent of a half. Where did you take this from? It was a square root. So guys, this one is just a repetition. We had this. It was a square root before. So bring back that square root. So therefore, our derivative of y with respect to x is equal to what? 3 over 2. Remember, the x is on its own. This one, it's on its own. So it means we are going to have the square root of x from there to the exponent of a half. It means what? Square root of x. What about this part? Is there anything that we can do there? Nothing. Nothing at all. It's nothing. It's already positive. We do not have fractional exponents where we can end up with a said like this. In this case there, we do not have. So first, rewrite in a way that you can differentiate x, where you can see x raised to a certain exponent. Then you differentiate. You drop the exponent, you subtract 1 on that exponent. Just like that. So please do revise as much questions, guys, as you can. Differentiate from first principles. 4 marks for that on question 5.5. First derivative of x from first principles. If f of x is minus 6x squared. So also, first principles as it is, you are given this from your formula sheet, guys. If you're in case that you've forgotten, dy dx is taken from this, from the first principles. That's your first principles formula, this one that we see here. So that's the formula that we are going to take into consideration and just make some adjustments. Just to make some adjustments as we are solving. Remember, it was minus 6x squared, our f of x. So that's 5.5. Our f of x was given as minus 6x squared. That's minus 6x squared. And from here, we are asked to differentiate first derivative from what? The first principles. So you saw that from our formula, guys, of the first principles, it will be like this. dy dx, which is the first derivative with respect to x, it is given that the limit of h will approach to 0 when we are given f of x plus h minus f of x, everything over what? Everything over h. So guys, knowing that we are going to need this on our formula, just find this, guys. f of x plus h. Then also subtract f of x, this one. Find this at once. What am I trying to say? Here, put those guys, substitute everything. F of x plus h, what does it mean? I talked about this, guys. You substitute where x is. You put what? X plus h. So it will be minus 6. Where you see the x here, put what? X plus h. So that's x plus h squared. So guys, if you know the expansion of a plus b squared, that it's a squared plus 2ab plus b squared. Guys. Knowing this, is there a difference here? Just because this is x, this is h, is the same thing. So you can also use the same situation. So knowing this, you know that you simply know that this was going to be what? X squared plus 2xh, 2ab plus what? Plus b squared, which is in our case is what? It's h squared. Yes, you can have your two brackets, h plus x plus h, another one, x plus h, like that. You expand. Guys, it's possible. You can do that. I'm not saying it's wrong. I'm not saying it's wrong. You can do that. But if you know your identities, it becomes easier. If you understand this, expand this, that'll be negative 6x squared, negative 6 times this. That's negative 12xh, negative 6, and this, negative 6x h squared. So this is our f of x plus h. On our formula, we need the difference. We can even find that, guys. Yes, you can substitute to say, okay, I have my f of x plus h here. Then I can even substitute it. I can even simplify it here, guys. Here. F of x plus h minus f of x. I can even find it here. Let's find it. I talked about this, guys. You take this is your f of x minus 6x squared minus 12xh minus 6h squared minus f of x minus f of x. We are going to subtract this here, our f of x, which is minus 6x squared. That is what it means. So guys, knowing this is important. Minus, that's a plus. So definitely this was going to cancel. Minus 6x squared plus 6x squared, it was going to cancel. You remain with this. This is what you need, guys. This is the one that we need. The f of x plus h, this one. F of x plus h minus f of x, this one. The one that we got here. Exactly this one here. We're just going to sub this one. We just need this. We can even simplify, guys. Don't make your formulas complicated. You bring a lot of things. You want to substitute. You want to subtract at the same time. You have confusion. Just simplify them there. Put the substitution now here. After that simplification. And knowing this, you're not going to have challenges in your N4. You are not going also to have challenges in your N5 because you're going to use this situation. All right, so just continue with it, guys. It's going to be easier for you. So this is it. The first derivative with respect to x is going to be equal to the limit as h approaches to 0 of what? This part. We simplified it as it is here. This is the one that we got here. So we're going to substitute here, this part as it is. So we got what? Negative 12xh minus 6h squared. Everything over what? Everything over h. Remember, we cannot use these limits because of the h in the denominator. Once we put a 0 now at this stage, once we put it means our answer will be infinite. We haven't solved anything because the denominator cannot what? Cannot be 0. So what can we do? We can get rid of the h from the numerator. Factorize the h there so that we can get rid of this h in the denominator. So we factor it out from the numerator. It is there. Factor it out. What are you going to have? Minus 12. So you're going to have minus 12x. The h and the h was going to cancel. All right. Minus 6h squared divided by h into this. We're going to remain with 1h there. So that's minus 6h. Just like that. Just like that. Everything over what? Everything over this h, which is in the denominator, this one. The one that we wanted to get rid of, because these two are the same, they can cancel. Remember, it's under what? A product. So you can cancel these two. So thus, we can use our limits. Remember, we are saying the limit of h must be what? Must be 0. So wherever we see the h here, wherever we see the h, put a 0. Wherever you see that h, those are the limits, put a 0 there. Wherever you see h, put a 0. So this part here, you're going to put a 0. So it will be minus 6 times 0 like that. We are now substituting the limits that you are given. That is what it means. So it will be minus 12x minus 6 times 0 like that, which is what? Which is minus 12x. This is exactly the first derivative of what? Minus 6x squared. It's going to give us minus 12x. First principle. Know your formulas. So this adjustment, like I said, guys, it can be done on its own. This one. Work it out, then put it back here. On this, on this formula here, you put it back. Just like that. Go through your questions. Also, you can verify this. Remember from the formula, minus 6x squared. If you differentiate this, what is the case? You drop the exponent, then you subtract 1. 2 times minus 6, that's minus 12. You subtract 1. So 2 minus 1 is what? 1. So that's minus 12x, exactly what we have. But they wanted you to use a certain method. First principles. So you must follow the instruction that you are given using this, follow that. So that was it, question 5.5, 4 marks. Then there, 5.6, fig 4 shows the graph of f of x. So this is our graph f of x. Use or make use of differentiation to determine the coordinates of the turning point B, this point B. The coordinates of the turning point. So guys, the coordinates of the turning point is direct. Remember, this is a turning point. Also, here it's a turning point at A. So A, they gave us the coordinates. That's at 0. They want us to find at B. So how do you find that, guys? We simply use the derivatives. Also, if you've forgotten, guys, the formula sheet, they also mentioned about that. That for the turning points, what are the conditions? For the turning points, which is for the maximum and minimum values, those are your turning points. The first derivative must be 0. At least you have a hint there, guys. You have a hint. So you can just have that as a continuation at any turning point. At any turning point. At any turning point, the first derivative must be equal to 0. So let's simplify the first derivative from our f of x. If our f of x is given as 6x squared plus x cubed, what is the first derivative, guys? I talked about this, guys. You drop the exponent, you subtract 1. You drop it, then you subtract 1. So 2 times 6, that's 12x. You subtract 1. You do the same thing. You drop the exponent, you subtract 1. So 3 times 1, that will be 3x squared. You subtract 1. So that's 3x squared there. Just like that. This is our first derivative. And at this turning point, this first derivative must be equal to 0. Knowing this, we are simply going to form an equation that this here is equal to 0. 12x plus 3x squared is equal to 0, where we can solve for x, a quadratic, a binomial in that case, 2 terms. You can simply factor out x, highest common factor. When you're given this, guys, just factor out your highest common factor. What is your highest common factor? Here is what? It's x. In terms of x, yes, we can factor out the 3, it's fine, but just consider the x there. That will be what? 12 there plus what? Plus 3x, which is equal to 0. So one of these brackets, or one of the terms, because it's a product, x is equal to what? X is equal to 0, or this bracket must be equal to 0. So we can find the x value from there. 12 is equal to the 3x to the other side will be minus 3x. So you simply divide by -3 by -3. So x is what? 12 divided by -3, which is what? Which is -4. So these are the possible values of x. Possible. But as we need exactly what represent they specified at B, the coordinate for B. Where is B here? This is our y-axis, remember, our x-axis. The first turning point is here, where it's 0, 0. So meaning to say our x cannot be 0 because already it is represented there. So the x that is remaining is what? The -4. Does it make sense that here we've got -4? Yes, it's on the left side. Remember your y-axis. So this is the left side. And on the left side, x is what? X is negative. So it does make sense that our x is what? -4. As we need the value of y now as a point, so substitute into the original equation, into our f of x, we are going to substitute the x that we are saying it is the 1. So that's 6 into x squared minus 4 squared plus x cubed. That's -4 to the exponent of 3. So that was going to give us the y value, which is 32. So therefore, our turning point there, B, is what? A point is given with x and y. So x is -4. The y value there is what? Is 32. Just like that. Just like that, you're done. So guys, do revise, work out many questions. It's very, very important that you figure out how these questions are being given. Then you play around. It's a play around. You're given your question, then you play around with the question. Figure out, how am I given this question? How can I obtain this? It's a matter of what? Figuring around. So question number 6, we are given, use the trigonometrical identities to prove that. So just prove this. All right, so you can choose the left-hand side, you can choose the right-hand side. It's our case here. So let me start with the right-hand side. Let me choose this. The sec of x minus the tan of x squared. Remember from our trigonometry, those ratios, identities, we have to play around and figure out. So all these guys, we are given the sec, the tan. So take note if you are dealing with a sec. All right, they just gave us a tan here. Tan, sine over cos. Then for, all right, for a sec, they did not like mention, they mentioned in another way to say 1 over sec, it's cos. So you just do the same thing, guys, to say 1 over cos. So it's going to be what? Sec. So it's just opposite. Sec 1 over cos. Cot 1 over tan. Cosec 1 over sine. Just like that. You can figure out that way, all right? So I hope you're together there. So that was the case that you're simply going to use. The sec, we have this, we said is going to be 1 over cos. So that's 1 over the cos of x minus tan. Instead of using that one for cot, we can use the tan direct, guys. It was sine over what? Sine over cos. So that is the sine of x over the cos of x. This one is just substituting, guys. Guys, this part is even difficult to explain because it's just like a follow-up. You just need to know your ratios and just substituting, guys. Remember, you're proving. So yes, we can expand our brackets, but before that, let's combine. The denominators are the same. So in the denominator of the cos of x, I can easily combine the numerators together. So that's 1 minus the sine of x. Everything is being squared, remember? So we're back. The expansion, our exponents tells us that each part is raised to the exponent of 2. So it's 1 minus the sine of x squared over what? The cos of x raised to the exponent of 2. That's cos squared x, like this. All right, let's check what we have on our answer. There is a sine. It's all about sine on our answer. Our answer is all about sine. So this one, at least there's something about a sign. So let's not expand it because already we have got a sign. So it's the same as we've got 1 minus the sine of x into 1 minus the sine of x over what? Cos squared. Do we have any equivalent for this cos squared? Let's go back to our formula sheet where there is cos squared and sine. Yes, here sine squared plus cos squared is what? It's 1. So we can make the cos squared to be the subject of the formula by taking the sine to the other side. So it will be 1 minus what? Sine squared theta. So in place of cos squared, guys, 1 minus sine squared can be what? Can be used. Know your identities. How to apply this. It is very, very important. Very, 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 very important. So we saw that this will be what? 1 minus sine squared x from our Pythagorean identity that we have there. Simplifying this, we are going to see, notice there's a difference of 2 squares. 1 squared minus sine x squared, same as a squared minus b squared. So that's a difference of 2 squares. So that is it, guys. So the first part on the numerator, just rewrite as it is. Then apply your difference of 2 squares. Remember, you're going to have a minus b into a plus b, 2 brackets. So it's 1 minus the sine of x. Another one will add 1 plus what? 1 plus the sine of x. Just like that. These two can cancel. So we remain with this. Is it exactly what we have on the left-hand side? 1 minus the sine of x over 1 plus the sine of x. Exactly what we're given on the left-hand side. You can also work from that left-hand side, guys. I want you to work it from there. Try to prove, but always try to work with the complicated side, guys. Always try to work with the complicated side. But what I'm saying, you can even work from the left-hand side. It's up to you. You can even work from there. So here, we worked from the right-hand side. This is what we have, something like that. Just make sure you combine as a single fraction, apply your identities. Check your answers as well. You see that your answer is in terms of sign. So don't cancel those sign. Leave them as they are until the last part maybe where you can see, no, this one can even be canceled. The sec also, this part of this sec, guys, you can even have them as you work from the left-hand side. It is up to, I mean, as you work for, guys, we're starting from the left-hand side to the right-hand side. Just forgive me the way that I wrote there. I don't know what happened. All right. But we can even have it from where? From the right-hand side. This is the sign that the mind is tired, guys. The right-hand side is 1 minus the sine of x over what? 1 plus the sine of x. So we just need to figure out, like, to have this. Okay, let's get rid of the denominator. Introduce a negative. We know that if you're given this same type, just gonna try to have a difference of 2 squares there. Okay, so that means here these two are the same. So just gonna have 1 minus the sine of x squared over what? A difference of 2 squares, isn't it? Difference of 2 squares. This one is a plus, this one is a minus. So it was taken from 1 minus what? Sine squared x. Expand these brackets. Remember the a minus b squared, guys, is going to give us a squared minus 2ab plus b squared. Remember this. So it's going to give us 1 minus 2 sine of x plus sine squared x. There, guys, I want you to expand. I'm not going to take my time. But I want you to expand that one. You're going to get something like this. Then from there, we can even bring back 1 minus sine squared. Remember, it was taken from cos squared. We saw that from the previous case. So this one going to be 1 minus 2 sine of x plus sine squared x over the cos squared of x. So this is where you are. You can even divide each and every term by cos squared. Cos squared, each and every term, 1 over cos squared. You can even separate 1 over cos squared 2 sine x over cos squared. So this one was going to be a lot. But guys, different methods. Remember, it's exam. So you can even work the way that you want. So you can even take this. 1 over cos is what? It's sec. So that's sec. Sine over cos. Remember, there are 2 of them. So it's like this. Sine over cos, like this, times cos. So sine over cos like this one. It's a tan. So that's minus 2 tan x. Then what about 1 over cos, which is remaining? 1 over cos, remember, is what? It's sec. So it will be 2 sec, 2 tan, minus 2 tan sec, all right? Plus sine over cos. Remember, sine over cos is tan, but there's a squared, so it will be tan squared x like this. Guys, this is an identity, this one, which was being taken from a minus b squared. Remember that part of a minus b squared that I was explaining from the first equation. This is your a, this is your b, if you have to check it properly. And this is minus 2ab. So it was taken from what? If you understand this, guys, it means it was taken from what? It was taken from a minus b squared, our a, which is the sec of x, minus our b, which is the tan, that's the tan of x squared. Algebraic identities, expansion. If you understand that expansion, therefore you must also understand its factorization. Before, how was it done? It's in your hands. As you can see, it is exactly our left-hand side, sec minus tan x squared. So this is exactly our left-hand side. Just like that. So guys, do as many questions. Figure out how these questions are given. Attempt try to do as many questions before your exams. Then on another part, these ones, they are just clear from the origin. You've got this P, which is K1. Remember a point, that's XY there. So K, just like the X values, these are the Y values. All right. So K is this part. Then the Y value is 1. Remember, it's K, it's 1. So it's, P, it's K1. So it's just like we've got 1, and the wall of this distance is what? Is K. The wall of this distance, which is our radius, is what? The square root of 5. So this is our information, this and that in the second quadrant, all right? Then from there, determine the value of K. From where? Where can we have the value of K? We have got a right-angled triangle, so Pythagoras can be used. 6.21, we've got 2 sides, remember? So x squared, remember, plus y squared is equal to r squared. X, k squared, plus y, which is 1, so that's 1 squared, equal to r squared, that's the square root of 5 there. So that's the square root of 5 squared, like this. So that will be k squared plus 1 is equal to square root of 5 squared is what? Is 5. Take this to the other side, it was going to be a negative 1. So that's k squared is equal to what? 4. Introduce the square root, guys. You want k, remember? So it's square root, plus or minus 2. So k can be positive 2, it can be minus 2, but which one is the exact value of k? From the origin going to the left, those are negative values. So therefore, our k was going to be negative 2. So that's negative 2. So, guys, this is just Pythagoras theorem that you can even look it by looking into the question. You can even just fill in, guys, and write your answer there. 6.22, the tan of theta. The tan of theta from our soccer tour. Remember this soccer tour. So the tan of theta can be determined. All right. The tan of theta, opposite over what? Opposite over adjacent. So according to this angle inside of the triangle, this one that is inside, which part represents our opposite? The one that faces there, that is our opposite. This is our adjacent. This is our hypotenuse. So it's opposite 1 over adjacent -2. Just like that. So it's 1 over -2. You can even leave it like that, or minus 1 over 2, or just leave it like that. Okay. So that is the case of our part there. Cos 180 plus theta, remember from reduction, this can be reduced. Cos 180 plus theta, it lies in the second quadrant. This is where we have got 180 plus, sorry, guys. This is 180 minus theta. Sorry for that. All right, 180 plus theta, it lies in the third quadrant. It's there, here, in this quadrant. And from our cast, right? Remember our cast concept. This third quadrant, cos is what? Cos is negative there. Cos is negative. It is the quadrant for tan. So cos is negative. So this one will give us minus cos what? Minus cos theta. You reduce it first. Then you can apply your ratio. Now, what is the ratio for cos? Cos is what? Adjacent over hypotenuse. So we need adjacent over the hypotenuse. What is our adjacent? So that's minus adjacent. That's minus 2 over the hypotenuse. Adjacent over hypotenuse, which is what? The square root of 5. So the hypotenuse is the square root of 5 like this. So looking into our question, we can see negative, negative. That is going to give us what? A positive. Negative, negative. That will give us a positive. So you can even leave your answer like that, guys. Simplification is not even necessary there. All right, then 6.3, we are given, consider fig 6 below. We've got points A, B, C. The vertices of quadrilateral. A, B, C, D is a point, and we've got B, C. This and that. All right, determine the length of AB. A, B, A, B, A, B, A, A, D, sorry, the length of AD, this one, AD. All right, so as for AD, guys, just take note, this is a triangle, non-right angle triangle where we are given two sides, this side and this side, but we do not have an angle inside. We can have this angle E here. Let's find this angle first. Angle AED can be calculated. Remember, angles on a straight line, they add up to 180 degrees. So we're going to remove these angles that are on a straight line, the 32 and the what? The 40 degrees. Subtract these two angles from what? From 180. That was going to give us 108 degrees. So that's our angle here, 108. Using the cosine rule, angle, guys, given an angle that is in between the sides like this, the cosine rule can be used. Remember your cosine rule, guys, you write it in the way that you understand a squared is equal to b squared plus c squared minus 2bc cos a. Minus 2bc cos of what? Cos of a. Where a squared is the side that you want to calculate. AD is the side that you need. B and C are the sides that are creating the angle. Any one of these, you can use AE. You can use what? DE. The sides that are creating this. Minus 2BC, the same sides. When you say minus 2B, see this one. Right here, it has shifted. I don't know how did it shift. So you said AE squared plus DE squared minus 2BC. It means those two sides again. The one that you multiplied here, the AE, and what? And the DE. Then cos of the angle, which is in between these two sides, which is cos of what? 108. And that is an included angle. It's called an included angle. That's simply cos what? Cos theta, which is cos E, our angle there. So it's cos angle E or AED. But that's angle E there. This is just writing. Knowing this formula, write down this one. Substitute, because you understand that one. So you're going to substitute our AE, that is 3 squared plus DE, which is 4 squared minus 2 times those sides B and C. So it's 2 times 3 times 4. 2 times 3 times 4 times the cos of the angle, included angle, which is 108. All right, just try to simplify, guys, stage by stage on this part. Stage by stage. 3 squared is 9. Just try. All right. 4 squared is 16. You multiply these numbers here, only these numbers. Minus 2 times 3 times 6 times 4. Sorry, that's 6 times, which is going to be 24, negative 24. So that's negative 24 cos 108. Add these two together, combine these two. So that was going to give us 25. So that's 25. 25 minus 24 cos what? 108 degrees. This is our AD squared. Combine everything here on your calculator. Use your calculator. The calculator can simplify this. Don't subtract these two, these ones. Never make a mistake. Combine everything on your calculator. Combine everything on your calculator. So it was going to give you 32.416, something like that. Then introducing the square root, thus having the value of what? AD, getting rid of that. To 3 decimal place, we're going to have 5,694 in meters. Remember, 3 decimal places as per the instruction of our question paper. So that was it, guys, on this part. That was it here, 6.3. All right, so we just need to revise, guys, as much questions as we can. Just try to make sure you work as much questions as you can. It is important in your revisions. All right, so you also need to consider that will be 6.4, the last part. I had it here. All right, so it's here. All right, no problem. I have it on this other part here. So if you are to check, sketch the graph of f of x. You're given, that's our 6.4, right? Sketch the graph of f of x is equal to what? So f of x is equal to 2 sine 2x plus 1 for this interval. So take note, guys, there's a number that you are given here, 2x here, this part. It affects this one, the 2x that we see here. It affects our period. Remember, the normal period of a graph of a sine is what? 360. So this one, it will be at 180. It will end at 180. It also affects the way that you separate your graphs. Remember, when you are drawing the graph of a sine, you were having something like this, which is separated 0, 90, 180, 270, 360. You're separating 90, 90, 90, 90, 90, like that. So this number that we are seeing, it also affects that part here, the 2. You divide by this. The period is affected. It was 360 degrees. You divide it by 2. It now complete its cycle at 180 when it is like that. In terms of the steps that you use when you're using your angles, 90 degrees, remember, you divide also by 2. So you're going to separate your angles 45 degrees, 45 degrees, 45 degrees from each other. So we can simply have our table. Knowing this, guys, we can have our table because we know they are separated by what? By 45 degrees from each. So we are going to have our xy like this. 0 degrees, 45 degrees. We add another 45, that's 90. Another 45, that's 135. We add another 45, that is 180 degrees. So guys, with this information, it is enough for you to, all right, I'm using this other board, guys, just forgive me because of this last part of my question. So this is the case. Using this information, guys, you can simply substitute on your calculator as it is. Make sure that you substitute properly. 2 sine, the calculator, it opens a bracket. You multiply 2 times the angle that you are given. If it is a 0, close the bracket. Then add a 1 aside. Close that bracket. So it was going to give you a 1. You move on when it is 45, put 45 degrees here in place of that 0. Remove, put 45. So you're going to get a 3. If you substitute that, it was going to give you a 3. For 90 degrees, you put 90 degrees here. It was going to give you a 1, a -1, and a 1. This is what you're going to have. With these points, guys, in our answer book, as we are being taught, in our answer book, it is enough. Just gonna have our sketch here. Separated by these guys, it's enough. Like just gonna have something like this, x, y like this, that's a 0. So remember, I've got 45, 90, 135, and 180. These are the important. Yes, you can use other angles. There are so many that you can use, guys. So let's mark our points. All right. Before that, we need the maximum value there is what? 3. So that'll be like 1, 2, 3. All right. Just maybe up to 4, minus 1, minus 2. So meaning to say we're going to mark our points. That's 0 versus 1. 0 versus 1. It's here. 45 versus what? 45 versus 3. 45 versus 3, somewhere there. 90 versus 1. 90 versus 1, somewhere there. 135 versus minus 1. 135 versus minus 1, somewhere there. 180 versus 1. 180 versus 1, somewhere there. Remember, it's a sine. It's the graph of a sine. It still maintains the shape because of what? Here, it's positive there. The shape is still maintained, guys. The shape that we know of a sine wave, only that it has been adjusted in terms of being shifted, this and that. But the shape remains the same, like the way that our sine, the graph of a sine, is supposed to be. So it goes to this, which is our maximum value. It goes to this 90 at 1, whatever part that you're going to have to the minimum value. Then it goes to the 180 versus what? 1. So that is how our graph was going to be like, where this point here is 180 versus what? Versus 1. All right. This point that we are seeing, it's a turning point there. 135 degrees versus what? Minus 1 is in the negative. This point is a turning point, 45 degrees versus what? 45 degrees versus 3. Y there is what? Is 3. Just like that. So it starts at this point, it goes just something like that. So that was it. Do revise, guys, as many questions as you can. As many questions as you can. So let, in our revisions, let there be light as we are revising, guys. Let's continue to make more questions, requests. The comment section, that's the purpose of the comment section, guys. If you keep that in your mind, it will stay in your mind until exam. But if you communicate, then we can also try to reach you out. So let's try to work out much questions from now. Prepare yourselves for the tests, the exams which are ahead of time. Till we meet again.